Okay, so question number 4 is a graph question. So we're looking at graphical representation of data. So a pupil used a sensor to record the change in pH of 10 cubic centimeters of an acid solution. When an acid solution was added a little at a time, the concentration of the alkali and the acid were fixed. Volume of acid added, so from 0 to 20, and pH of resulting mixture. Okay, so volume of alkali added, so you started off with 10 of acid, then you added 2 cubic centimeters at a time of alkali, so you're looking at a neutralization reaction here. So we're going to have to plot the graph with the data. You can try and fit both of them on the page, that would be good. Okay, so I'm just going to do one for you so you can see what's happening on here. The little graph is quite small, so it's difficult to use the pen to write on the screen. So volume of alkali 0, 0. Volume pH of resulting mixture 5.0. So the one that's going up in regular intervals is the volume of the alkali. So I'm going to put that on the bottom. So we're going to put here vol of alkali. Okay, because that's going to go up in regular numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that fits in there perfect. That's a little bit further over that line. Sorry, the pen just doesn't put in the right place for me. Okay, right, so we know, based on that, we know that we have our independent variable on the x-axis, and on the y-axis we're going to put the dependent variable. So our smallest number is 5 and our biggest number is 9, so I have to find numbers to go up to include those. So 1, 2, 3, 4, 5, 6, 7, 8, 9 fits on perfect. It's like they organized it for you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right, so and on the side here we're going to put pH of mixture. Volume of acid. Now I better put units on here. cm cubed, and we don't have any units for our pH, so we're going to leave that the way it is. Right, okay, so first number is whatever the number is on. So this is, what do we say, this is 2, 4, 2, 4, 6, 8. (10, 12, 14, 16, 18, and 20). And then again, going up in ones up along the side. Okay, so next, the first number was 2 and 0 and 5. So we need to draw a line, or draw a dot, sorry. Number 0 for the volume of acid and pH of 5. So just put a little dot there. Okay. And I'm just going to point to where you put the dots because it's not working for me putting the dots. Okay, the next one is 2 and 5. Two and 5. Oh, there we go. I managed a little X there. Put a little X in those 0. Okay, so we're managing little X's now. Next one is 2 and 5. And 6 and 5.5. 2 and 5, 4 and 5, and 6 and 5.5. So we're going to go halfway here. So there's 5, there's 6, there's 1, 2, 3, 4, 5 boxes in between. So it's going to be 2.5 up to 2.5 here. Okay. 8 is 6. 10 is 7. 12 is 8. 12 is 8. 14 is 8.5. 14, 8.5. 2.5 there. 18 is 9. Sorry, 16 is 9, 18 is 9, and 20 is 9. Okay, so there is your graph. So look on the graph. What would be likely pH of the solution if the pupil added 2 further cubic centimeters of alkali solution? Okay, so have a think about that. I'm just going to tell you where we would have awarded marks for on the graph. So you would have had 1 mark for labelling the axes. So there's your axes labels here and here. If you didn't have the units, you wouldn't have got the mark. Plot the points, you would have 1 for plotting the points. Okay, and then the next one was for drawing a smooth curve. So we'll see, there's your smooth curve. Let's start a little bit further up here. There you go. So you would just rub that out and sort that out a little bit better, but that's your smooth curve. Okay, so just 1 smooth pencil line. Okay. So yeah, so what would the likely pH of the solution? Okay, so the answer would be pH 9, because you can see here is acid, here is alkali, and it's already reached the neutralization point, so 9 would be answer, so 9.0. So that concludes question number 4.